Here is a combined summary of the 4 pages. The paper introduces Versus Debias, a novel and universal debiasing framework for text-to-image (T2I) models, addressing social bias against demographic groups, particularly women and colored races. The framework consists of a generative adversarial mechanism, GAM, and a debiasing generation mechanism, DGM, using a small language model, SLM. GAM generates specialized attribute arrays for each prompt, diminishing the influence of hallucinations from T2I models, while DGM uses prompt engineering to generate debiased prompts for the T2I model, providing zero-shot debiasing ability and custom optimization for different models. The pipeline of Versus Debias consists of a generator, a discriminator, and a dataset. The discriminator employs a multimodal language learning model, MLLM, to perform zero-shot semantic alignment on generated images, extracting information on gender, race, and age. The alignment results are statistically averaged to determine the generative demographic proportions of 3 protected attributes for each main prompt. The discriminator then compares the proportions of each gender, race, and age group to the ground truth and modifies the prompts by adding underrepresented protected attributes. The generator uses the fine-tuned SLM to accurately extract the potentially bias-inducing main prompt from the user prompt and adds an appropriate protected attribute based on the best results. The framework is compatible with various T2I models, including diffusion-based and transformer-based models, and uses Comfy UI as the tool to connect Versus Debias with T2I models. The dataset creation process involves consolidating occupations from the Bureau of Labor Statistics, adding descriptions of image quality and character states, and generating 20 prompts for each occupation. The paper presents Versus Debias, a novel debiasing technique for text-to-image (T2I) models, focusing on improving accuracy and fairness by addressing gender, race, and age biases. The technique involves weighting these biases and using a specialized dataset to fine-tune the model. Comparative experiments with state-of-the-art SLMs and LLMs demonstrate the performance of Versus Debias in both few-shot and zero-shot scenarios, showcasing significant improvements in debiasing, particularly in race and age, with higher accuracy and fairness. The model's effectiveness is further highlighted by its ability to improve the performance of a model that initially performed poorly. The attribute array length is investigated, revealing that increasing the length leads to smoother variations in demographic proportions, enhancing accuracy. The paper contributes significantly to the field of debiasing in T2I models, offering a promising solution for improving fairness and accuracy. Versus Debias is also introduced as a universal debiasing framework for T2I models, enabling precise and efficient debiasing through prompt engineering. The framework comprises a novel generative adversarial model, GAM, to generate corresponding debiased attribute arrays and an advanced SLM for editing prompts. Extensive experiments validate that Versus Debias surpasses existing methods in both zero-shot and pre-learned situations, maintaining the original model's image generation style and quality. The paper acknowledges limitations in future work, including the need for better model classification and handling extreme cases of hallucinations. The pages delve into the intricacies of text-to-image generative models, particularly emphasizing multimodal LLMs and latent consistency models. A key focus is on fairness and bias mitigation, referencing studies that reveal implicit bias and social biases in grounded vision and language embeddings. The summaries also underscore the efficiency and effectiveness of diffusion models, including adversarial diffusion distillation and safe latent diffusion. Moreover, they stress the necessity for fair human generation and mitigation strategies in text-to-image models. Limitations and future work in this field are discussed, highlighting the importance of transparency and accountability in AI development. This comprehensive overview provides insights into the current state and potential advancements of text-to-image generative models, emphasizing the need for ethical considerations in model development.